for longevity, we expected omega-3s to be at the tip top of the list, and instead it was C15.
It only takes like 60 milligrams of vitamin C to cure scurvy, which is a deadly disease if you don't have enough vitamin C.
The latest paper showed 38% of people globally have fatty liver disease.
Dr. Stephanie Venn-Watson, a veterinary epidemiologist.
She uncovered the powerful health benefits of C15
in longevity and disease prevention.
If we don't have enough C15, our cells become fragile. People with higher C15 have lower risk of developing type 2 diabetes and certain types of cancers. We did 2 Navy-funded studies in which we gave those dolphins a higher C15 fish diet, and we saw that their aging-related conditions reverse. In Sardinia, the people there, they live longer in part because they have a lower risk of developing heart disease. They have a mean C15 level of 0.6. For the people who took C15 supplementation, they had lower liver enzymes, lower ALT, lower AST, and improved.
Stephanie, it's great to have you back on the Dr. Hyman show.
Yeah.
And your work continues to astound me, and discoveries that I think are going to hopefully make us all live a little bit longer, feel a little bit better, prevent some of the disease of aging. And we're talking about today the work you've done as a veterinary epidemiologist working with the Navy the Navy Dolphins.
We're going to help with Navy SEALs too.
I feel like a Navy SEAL right now. I'm like trying to not shiver to death, and I'm not in freezing cold water, but I'm wearing a thick coat because we're in Austin, Texas, and it is freezing out. With the wind chill, it's like day. Minus 12 degrees or something. So I'd love to start by having you sort of describe the sort of this incredible work you did with the Navy Dolphins, which are used for kind of, what are they used for? And then what did you find as sort of you looked at the natural lifespan of dolphins compared to the dolphins in captivity, and how did that start to get you thinking about the sort of longevity aspect of what might be in the dolphins that you could discover, and how did you begin to discover that? So,
yeah, boy, this is going to be exciting talk. I love the tee up. Dr. Hyman, it's great to be here. It's always good to see you. So as a veterinary epidemiologist, I was, wanted to track diseases. I read Laurie Garrett's The Coming Plague when I was an undergraduate and said, I want to do that. And I thought it was going to be infectious diseases. And it ends up that thanks to being recruited by the Navy to help lead their clinical research program with their dolphin population to help improve the lives of their dolphins, it quickly pivoted to chronic diseases and chronic diseases of aging. So it's been
dolphins get chronic disease of aging? This doesn't make any sense to me. They're not eating McDonald's, and they're not exercising, and they're not doing their normal sleep routine, and they don't. I mean, maybe they have more stress living in captivity, but...
Right. Well, that was the key question, right? It really, you hit the nail on the head. That moved over to the Navy, ended up spending 20 years there, 10 full years working with the Navy's dolphins with the pure goal of improving Navy dolphin health. So Navy dolphins, they live in San Diego Bay, go out into the open ocean every day they choose to come back. So it's a pretty nice environment with regard to quality of life.
They're free to go and then they come back?
Yeah. It's pretty amazing, right? So they live in the open ocean. That's their pod. So they choose to be there, and it meant a lot to me as a veterinarian. I didn't know how I'd feel.
I mean, also listening probably go, well, wait a minute, why does the Navy have dolphins? Like, they're not...
Right. Yeah. So it ends up that they're really good at being able to find underwater objects that we can't see very well. And so they've done humanitarian demining missions in the Mediterranean where they're able to find buried mines, target it. They mark it, and then humans come in. And
things left over from World War II or whatever, right?
Exactly. So they have now made entire areas of the world safe. Which is amazing. They can also find underwater swimmers, enemy swimmers, and be able to interdict and put a leg cuff on those swimmers, and they get reeled up by their human counterparts. So,
wait, you mean enemy scuba divers?
Yeah, in case they were in nefarious areas, the Navy Dolphins are there to help. So for them, their job is easy peasy, right? They have echolocation, they're able to do these things. And the program has been so successful, being able to deploy the dolphins all over the world and have them stay, right? That has allowed, this program has been around for 60 years,
Amazing.
they've had a sustained population of 100 bottlenose dolphins.
Wow.
So that has resulted in, what we're talking about today with regard to this unprecedented patient population that gets older. Like you mentioned, that in the wild, dolphins live to about 20. At the Navy, they're living into their 50s and even up to 60 years old.
They're
So
living like 2 or 3 times as long
that's right.
in captivity as they do in the wild. Is that because there's predators or just it's more tough to get along out there? Or?
Great healthcare system, good preventative healthcare system, access to fish. You watch any kind of wild animal show these days, and the world isn't so friendly anymore for animals. It's getting harder and harder for wildlife.
Do you think the wild dolphins like a couple hundred years ago lived longer?
That's a good question. I do think there are things, there are studies that have shown that there were times that dolphins might have lived slightly longer, like maybe a few years, but nothing on the average like what we're seeing at the Navy. So there I was, right? So taking care of this older geriatric dolphin population. And what we started seeing, Mark, was an increase in that some of the dolphins were developing aging-associated diseases like chronic inflammation, high cholesterol, fatty liver disease, and even the full suite of changes consistent with Alzheimer's.
Yeah.
And what was really important was that some of the dolphins were developing these conditions, which has now culminated in what we now understand as a syndrome, that some dolphins were developing this and others were not. So we were able to go in, use metabolomics, which is this advanced technology to study thousands of small molecules.
In your blood, basically.
Yeah, exactly, in the blood. And we had this amazing archived inventory of dolphin serum, look at those molecules in their blood and in their all-fish diet to find which small molecules predicted the healthiest aging dolphins. We expected omega-3s to be at the tip top of the list.
Yeah.
And instead it was C15, which none of us even knew what C15 was, but pentadecanoic acid was the top predictor of healthy aging dolphins. So that was 10 years ago, and what started the next 10 years of research, now over 100 papers on C15.
It's incredible. So basically, this is C15 is and the number 15 is really about where the carbons and the bonds are on the chain of fatty acids, and it's a saturated fat, which in most people's mind think is bad, but it's actually not. It turns out to be very powerful and have many effects on many of the longevity pathways. And there's a lot of molecules that are being studied for longevity, everything from rapamycin to metformin to NAD, and the list goes on. Astaxanthin. I mean, there's a lot of interesting molecules that are being used. How does C15 stack up against some of these? What is the sort of the research that's been done today to help to look at what it does? How does it actually facilitate longevity? And because it's just a fatty acid, so you wouldn't think, how is it doing all these things, right?
Right. So the first important discovery that we made, and this was alongside Dr. Ed Dennis, who's a leader in fatty acids. So was the editor-in-chief for the Journal for Lipid Research for 15 years. And when we first made the discovery of C15 association, right, because in the dolphins, this was just association with better health, we went to Dr. Dennis, to Ed, and shared our hypothesis. And Ed was like, well, chances are this isn't going to pan out because we've known about C15 since the 1950s. And chances are that stuff, no offense, that a dolphin veterinarian didn't discover something new about fatty acids. And he's like, but it's intriguing about the dolphins. So we spent the next 3 years doing 8 studies to show that C15 not only has direct benefits and is a beneficial saturated fat, like you shared, but that it meets these rare criteria of being an essential fatty acid, the first essential fatty acid to be discovered in over 90 years.
What makes something an essential fatty acid? Because we think of these things as essential for life, and if we don't have them, you're going to be in trouble. Like there's essential amino acids, fatty acids. By the way, everybody, there's no such thing as essential carbohydrates.
It's a good point. Good point. Dang it.
But what makes it essential, and how do we have to think differently about it?
We did. Yeah. So what we've learned is that our bodies require a certain amount of C15 in our bodies, and including in our cell membrane. It's a sturdy saturated fat that is, because it's an odd chain saturated fatty acid, has an odd number of carbons, it has anti-inflammatory properties. We'll talk about all the different mechanisms that C15 has. So it's really this Goldilocks healthy fatty acid that is essential to maintaining the stability of our cells. If we don't have enough C15, specifically, at least 0.2% of C15 of fatty acids are C15 in our cell membrane, our cells become fragile and we develop a nutritional deficiency syndrome, which we published last year in Metabolites, called cellular fragility syndrome, the first deficiency syndrome to be discovered in 75 years, which leads to, we can talk about this whole new form of cell death called ferroptosis. So it's been, and accelerates
If someone
our
has
aging.
fragile cells, what does that mean? What are the consequences? How do they feel?
Right. So if you have fragile cells, your cells basically start falling apart, which is what happens when we age. So a lot of aging-related breakdown that we feel, our aching knees, our foggy brains, our slower metabolism, increased inflammation, all of those things come with more fragile cells, which leads to, if we nerd out a little bit, leads to lipid peroxidation. There's this abnormal iron sitting inside the cell. They combine and they cause this increase, like explosion of reactive oxygen species that take out the cell. So when that happens, our whole bodies get affected, from our immunity to our metabolism. So it ends up that while this process, C15 deficiencies, can accelerate our aging and everything that we feel with aging, we've now been able to work with the Navy and look at how can we optimize C15 to flip the story, and how can we actually optimize our longevity through C15.
So you talk also you wrote a book, actually just quite good. It's called The Longevity Nutrient, and the full title is The Unexpected Fat That Holds the Key to Healthy Aging. So it's kind of a good title. It got my attention. I actually have been measuring fatty acids in my patients for decades and decades, and I'd always see C15, but it didn't really register as something that was important to look at. And now I look at it every time, and I'm surprised to see how many people are actually quite low in C15, which comes from dairy products, right, and from fatty fish.
That's right. And so now we're seeing that as many as 1 in 3 people are C15 deficient. And then there's some that are extremely C15 deficient, right, which you'll see on your test. And it's exactly for that reason. We have taken C15 out of our diets globally. So our primary source, Mark, like you just shared, is dairy fat by far. And we're not saying go back and eat a bunch of dairy fat. 1% of dairy fats is C15. Over 40% of the fatty acids in dairy fat are pro-inflammatory saturated fat. So we still need to work our way through that. But the Navy was interested enough to say, hey, can we find a way to use C15 and leverage it for longevity? Meanwhile, let's also talk about the need to prevent these, deficiency syndrome that's showing up in our kids. And that might just be by helping to get milk fat back into kids' diets, including mom's milk fat.
Yeah, well, breast milk for sure, although conventional dairy has a lot of problems and is very inflammatory for a lot of people. And
that's right.
I wonder if it's high levels in goat or sheep. Is it?
It's a good question. So what the studies have learned is that C15 levels are driven by what the ruminant, so it could be a cow, a goat,
what you're eating,
what they eat. Yeah. So if you feed either cow, goat, or sheep grass, it has twice as much C15 in its dairy fat than fed corn. If you feed it high altitude grass, it has even higher C15. So, we don't know when you go buy your dairy product what that animal was eating. And so one thing that we're pushing for is to have the dairy industry report C15 levels in their foods, and to help change industry practices to help maximize C15 levels.
Interesting. Yeah. So you're not what you eat, you're whatever you're eating ate.
That's right. You've got that. Yeah.
Now let's get into some of the sort of I mean, the discovery of it's fascinating. So you've had this like trove of blood from dolphins for decades, and then you can go back and check, like, okay, who are the dolphins that aged fast? Who are the ones that aged more slowly? And then you kind of looked at all of them, and then rose to the top where was C15. But you mentioned there's like 100 other molecules you're looking at that may have promising benefits too that we haven't looked at. And that's the beauty of sort of modern science. For those listening, we really have gotten the ability to look at not just 20 blood tests, or at function we do 110, and there's now ways to do metabolomics, which looks at thousands and thousands of molecules that are floating around in your blood that have meaning and that do things, but that often we've kind of neglected or ignored. And this is clearly one of them. In terms of this 7 sort of longevity enablers you talk about, fatty 15, which is the sort of brand of the product, C15, which you can now actually buy, and I personally take it every day, because the science was so compelling to me that I was like, okay, well, this is, if it doesn't work, okay, but if I'm missing something, it's going to be a big deal. So I want to take it. What are the sort of 7, you call it, must-haves of a longevity enabler that this molecule meets?
Yeah, so we have established these 7 must-haves, and by we I mean the longevity scientific community. This was also put together in part with Dr. Nicholas Shork, who is the head of NIH's Longevity Consortium, and so Nick was really interested in the dolphin angle, because he's like, wait, you've got a long-lived species that has clean data. So let's work through that to make these discoveries. And when we get to these longevity must-haves, we're now able to, a lot of longevity research is on short-lived species of how do we help mice and worms live longer, right? And it's
We're good at making worms live to be like 1,000 years old.
And it doesn't really translate, right?
Yeah, and mice, to be like 120. But.
So, Nick and I really came in and we're like, oh my gosh, we have this incredible opportunity. Nature's already figured it out, right, Mark? I mean, nature's already figured out how a mammal can live 27, 30 times longer, because humans and dolphins and elephants live a lot longer than a mouse. So why? So let's figure out how evolution has already enabled massive longevity enabling, tap into that, and then make it even better. So
some of the bowhead whales have like 200 years.
Right. So it's just like, let's focus on these species, not to dismiss the short
science,
the basic science, but it's an unlock, right? So the 7 must-haves of longevity, and this is assuming that longevity, the way we define it is as a geroprotector, so a molecule that slows our aging rate and therefore slows the onset of the chronic diseases that kill us.
So you may not actually live longer, but you'll live healthier.
And then by default, be able to extend your own longevity. Right. So that you can live longer. So of those, the 7 longevity must-haves are, first, this molecule needs to tap into the longevity regulating pathway. It's this complicated KEGG. It's called the KEGG pathway, and it's based upon a hypocaloric diet. So caloric restriction and the whole pathway that's been built out on how caloric restriction extends longevity across multiple species. At the heart of it is activating AMPK and inhibiting mTOR, which, as you had mentioned, metformin activates AMPK, and rapamycin inhibits mTOR. C15 does both. So that was really exciting to see. It's really hitting at the heart as other longevity molecules. The second is that it needs to target.
And just to back up on that for a minute, because people might not understand that. So AMPK sort of regulates a lot of things: inflammation, your blood sugar control, your mitochondrial function, and interacts with a lot of other longevity pathways. I call them longevity switches, like the 4 longevity switches that I wrote about sort of in my book, Young Forever, which is, mTOR, which regulates protein synthesis, and also when you inhibit it, causes autophagy, which is cellular cleanup, which is really important to healthy aging. Insulin signaling, which we can talk about, and that causes us to kind of overproduce insulin and leads to obesity and diabetes and Alzheimer's and cancer and pretty much everything else. And then there's the pathway called sirtuins, which is very involved in regulating DNA repair and oxidative stress. And a lot of them have overlapping redundancies in terms of the key fundamental things of aging, which we talk about in the hallmarks of aging, whether it's mitochondrial dysfunction, whether it's autophagy, cellular cleanup, whether it's inflammation, oxidative stress, blood sugar regulation, protein synthesis. So all those things are necessary, and they're fundamental to understand, because they're the things that underlie all disease. And what people don't realize is now we're discovering these new frameworks for understanding disease that are based on root causes. And so the hallmarks of aging are really discoveries that have helped us map out what are those things that tend to go wrong as we get older. And now we can think about how do we treat those. And if we treated those, we might extend life by a third, rather than just, if we got rid of cancer and heart disease, we'd extend life by 5 to 7 years. We completely eradicate it from the planet. So that's not much of a life extension compared to 30 years, right?
That's right.
So they're really important to understand, but there's also causes of dysfunction, which I think doesn't get addressed. Like, why do we have these dysfunctions? But C15 seems to work on some of these key pathways around the hallmarks of aging.
That's right. Thank you for that. And your book, by the way, does a great job explaining all of those. So
it's hard to explain, trust me.
If anyone wants to dive in more, please,
Young Forever,
please read
it. Yeah.
Please read, your book, Young Forever. So, then the second one exactly feeds into the hallmarks of aging. There's 12. The list keeps getting longer.
Yeah.
It feels like every couple of
9,
years.
it was 10, 13.
Yeah. So there's now multiple studies showing that C15 targets 6 of them, and that includes helping C15 directly repairs mitochondrial function. It has the skip function where it's able to help restore broken mitochondria by enabling it to make energy when normally it wouldn't be able to, which is exciting.
Yeah.
And important. It helps with poor cellular signaling. We know that it not only activates AMPK and inhibits mTOR, but it also activates PPAR alpha delta and AKT, and it inhibits JAK-STAT and HDAC6. So that was a bunch of letters.
Yeah. What she's saying basically in English is that these are other pathways that we all have that regulate inflammation, that regulate blood sugar, and that when we look at actually the things that drive aging, it's dysregulation of blood sugar and insulin, and inflammation that is a consequence of that. And the downstream effects is it harms our mitochondria, it causes more oxidative stress, it has so many awful effects on inhibiting autophagy and causing stem cell exhaustion and shortening telomeres and all the things that I talk about in my book. So, when you kind of get to the kingpin of what's going on for most of us as we age, and what's so curious about these long-lived dolphins is that they have this protective molecule that they seem to accumulate. Now, what I don't understand is if all the dolphins were eating the same stuff and all of them had the same environment, like why were some actually having high levels of C15 and others? It's some genetic component here that we don't understand, or there's some variability in how people keep or utilize it or absorb it. What explains that?
Right. So with the dolphins, it was it ended up being pretty straightforward. So they have an option of 5 different fish types, or they might be fed different fish types based upon what their job is at the Navy. So if they're doing a job in which they're going through, training of learning how to find an object, for example, they might get a bunch of low-fat fish that they get kind of given throughout the whole day. Yeah. It ends up that those low-fat fish had no C15 in them. And what we were able to get to, remarkably, because the Navy's vigilant data collection, we were able to see that some dolphins were getting a higher C15 diet than other dolphins. And then even better, we did 2 Navy-funded studies in which we gave those dolphins with lower C15 a higher C15 fish diet, and we saw that their aging-related conditions reverse. So
that's amazing.
Right? So then we were like, oh, okay, now we're on to something.
That's how you test the hypothesis, right? You see, it's associated with longevity, but is it causal?
That's right.
And when you add the molecule into the diet through fatty fish, it actually reverses the things that you saw as consequences of aging.
That's right. We saw
So-
complete reversal of
So if
anemia.
you give the
for
fish,
example.
if the dolphin herring, that's good. But if you give them like flounder, probably not so good, right?
Yeah, that's right. It was not like a common food that we eat, but it was like capelin and squid. Squid had no C15 in it, but you're right. Herring was a great, and mackerel were great fish. So that's how it led to all of those. So then, with the hallmarks of aging, it targets 6 of them. It helps with, we now understand from a clinical trial, it helps with gut dysbiosis.
How does it do that?
Right. So C15, multiple ways. A lot of exciting research coming out on C15 for gut health, not from us, from other teams
yeah.
around the world. They've shown, multiple studies have shown that in multiple mouse models of colitis, of IBD, with regard to like leaky gut syndrome, that C15 specifically helps improve the gut lining, and it stops the leakiness. So it decreases inflammation and it stops the leaking.
Is it because it sort of embeds itself in cell membranes in the gut? And
that's
it
it.
becomes more stable and less fragile? Is that the kind of hypothesis?
That's the hypothesis.
Yeah.
We know that it gets in there. We know that it has this effect, and so it helps with that. In addition, really fascinating work on the microbiome that. In a clinical trial that was done in Singapore with C15 supplementation, showed that women who had a history of fatty liver disease, when they took C15, they saw an improvement in the growth of Bifidobacterium adolescentis, which is like a mama microbe that's really good at helping to regulate our metabolism. It's also been shown to extend longevity in worms. So we already talked about the limitation of that, but it was an interesting side
I
point.
knew that worms have a microbiome. I guess they do.
Exactly.
Worm poop.
It lowered, in that clinical trial, it also lowered LDL cholesterol, which was great. So, and then there are other studies showing that, that we know that fiber can help improve metabolism. And so there was a whole series of studies that was done to figure out how fiber helps. It ends up that there's a molecule in fiber called inulin, not to be confused with insulin. And inulin is being fed to our gut microbes that then use inulin to make C15. And so it's because of the C15 that's being made by the microbes that helped explain the benefits of fiber. So it's just like
interesting.
It's,
so
it's
basically,
essential.
you don't have to eat fatty fish or dairy. If you have enough of the right fiber and prebiotics, you can grow the right bugs in your gut, and
Yeah.
they'll produce C15 for you.
It'll get you to, it's like an additive. It's kind of like how to order all the different tips and things we can do to maximize our C15. So that is one component. If none of the single things alone can do it, but additively.
I mean, it's interesting. We've been measuring like fatty acids on our patients at the Ultra Wellness Center, my practice in Lenox, Massachusetts, for 20 years. Wow. And we, before that at Canyon Ranch, we also did for another 10 years. And, it would be interesting to go back and see, okay, who has low levels of C15? Because it wasn't something I was really paying that much attention to.
Right.
And now I pay very close attention to it. And I'm like, oh, wow, this one's low. You're low. You're low. You're low. You're low.
Yeah.
And I'm like, it's an important biomarker for actually understanding how people are navigating their health journey and longevity and aging itself. So really quite amazing. So we were kind of going through the 7 longevity must-haves. We went through.
So we got the first 2, which were the biggest.
Yeah.
In addition to targeting the longevity pathway, human pathway, regulating pathway, it also targets key hallmarks of aging. It needs to show, the third is it needs to show evidence of slowing the rate at which we age. And that's usually, we talk about Navy SEALs, right? So if this was a Navy SEAL course, this is where most longevity molecules would not make the cut and drop out of the competition. Yeah. So we did, Nick Schwark and I, we did a study showing dolphins showing what hadn't yet been proven before, which is if you take individuals within the same population, that there will be some that age at different rates, despite having a relatively controlled environment. And it was crystal clear in the dolphins that we had fast aging and slow aging dolphins. It ends up the aging rate biomarker for that was hemoglobin. And that had to do with, again, fragile cells in which they were increasingly losing red blood cell health over time. one measurement of that is called red blood cell distribution width, or RDW, which has become, see, there you go, a really popular way of understanding aging rate is RDW. So we saw that crystal clear in the dolphins.
Yeah, it's interesting. Actually, RDW is one of the biomarkers that's used to kind of calculate your biological age that we use at Function Health.
Yeah.
Which is based on epigenetic testing and correlating that with certain blood biomarkers. And that's how we come up at Function Health with a biomarker. So it'd be interesting to be able to start to test fatty 15 as part of our Function Health panel. But it's really, it seems like such an essential molecule. The fact that it's, quote, essential, is that something that's been established by the scientific community? Is that something that you just sort of figured out? Or
Right. That's a pretty bold claim.
Yeah.
Right? So we put the stake.
It's like discovering a new vitamin that's essential for health. Right.
Right.
It's a big deal. And it hasn't been a new one in like 70 years or something, right?
It's been a long time. Exactly. Yeah. So we put the stake at the ground back in 2020, and we published that in Nature's Scientific Reports. This last year has been really exciting, Mark. There have been now to date 3 other independent teams that have evaluated C15 as meeting the criteria of essentiality, all using different methods, of gold standard methods of looking at pregnant mice and saying, hey, if you make the mom C15 deficient, does her neonate show evidence of a nutritional deficiency? And the answer was yes. And when you give it just C15, does a nutritional deficiency, is it fixed? And the answer was yes. So like
an infant mice, what are the symptoms of nutritional deficiency?
Poor growth and poor neural development. It ends up that epidemiologically we're seeing the same trend, disturbingly, in humans, that if mom has lower C15 levels, her baby gets lower C15, and lower C15 now has been associated with poor body growth, poor brain development, even up to cognitive development of kids up to 6 years old. The upside, right? What's the hope in all of this is that nutritional deficiencies and essential fatty acids, right? These are fixable.
Yeah.
So now we have, with regard to essentiality, another study with worms showed that if you deprived a baby worm of all nutrients, right, it goes into this, it doesn't die, it goes into this like slumber state. And they showed that if you give it just C15, it will regrow as if you were feeding it a full nutritious diet.
Wow.
So walking through, and then another group looked at all the wealth of human data to date. And so all of these papers came out just this last year, again, revalidating that C15 meets the criteria of essential fatty acid, including, the discovery of a nutritional deficiency like vitamin C and scurvy and vitamin D and rickets.
So what has been the human data? I mean, we're talking about worms, we're talking about dolphins, we're talking about what's the human data on C15, and how does it stack up against, for example, other longevity molecules? Because the NIH has a program to study various compounds and looking at rapamycin or metformin or astaxanthin or acarbose, which most of these are drugs. And there's not a lot that actually show significant benefit. Rapamycin is probably the most promising, but it has significant side effects, and there's coming up with analogs that are without the side effects that only affect one of the pathways of mTOR, but that's way too complicated for me to understand. But tell me, like, how does this sort of stack up in that lineup?
Yep. So we'll start with human cell systems, because it's hard to do the long-term studies to show, hey, if you take this molecule, will you live longer? And to your
like a randomized controlled trial for 50 years to see what happens.
Yeah, and those are underway, which is good, but they just take time and they get really complicated. So again, working with Dr. Shork, one way we looked at that was to say, okay, we use this panel called Biomap, and they're human cell systems, 12 different human cell systems that are mimicking various disease states. And it has a bunch, 148 different biomarkers. And what you do is you treat these different cell systems, disease systems, with different doses, like ascending doses of C15, of rapamycin, metformin, acarbose. And what we showed was that C15 had the most cellular, clinically relevant benefits that are longevity enhancing compared to rapamycin, metformin, and acarbose, it was really close to, it was most close to rapamycin, which is exciting for the longevity consortium, right? They really leaned
It doesn't
into
have
that.
all the side effects.
Without the side effects. I mean, this is a molecule that every mammal gets at birth.
Yeah.
So, and then when you look, you step back a little bit and you look at the activities, the things we care about. C15 is anti-inflammatory. It has an antioxidant. It has anti-cancer functions. It has antimicrobial. It even stops the growth of pathogenic bacteria and fungi. And you look at that kind of wonky list of benefits, and that's what rapamycin does.
Yeah.
So it just means that maybe we didn't have to go to Easter Island to discover rapamycin.
Just San Diego to the Navy Dolphin
the
program.
Dolphins. And then it's like mama's milk. It's like, thank you, Mom.
Hard to get breast milk, though. You can't get that easily.
We don't want to, and no other mammal continues to eat dairy after the initial growth. So it's like, how do we leverage this molecule in our later years?
Well, that's a good point. How do other mammals, who are not eating fish, right? Like, you've got bears who eat fish, you've got, certain, other mammals that might eat fish, like otters or seals, whatever. But most land living mammals like elk or deer don't eat fish.
Right.
How do they get C15?
And they're not eating dairy, no ice cream, no cheese, anything like that. So there are plant-based forms, and there haven't been a lot of studies yet to understand what are the different C15 sources, because now that we understand C15's essentiality really expands to the animal kingdom as far as we know it, of how different animals get it. But it could be part of like cows make it, right? So they eat grass, and their rumen is able to their bacteria to produce it. So it may be a combination based upon the species, how well their microbes are able to make it from the food versus how much they get from the food directly.
So if you get regeneratively raised cows, they're going to be eating more variety of wild grasses and plants. They might have more.
That's right.
If you're eating sheep or goat, they typically don't, feed them corn and soy.
That's right.
So they may have more. And it's often better tolerated because they have a different form of casein, which is the protein in milk that tends to cause problems. And most cows are bred to have A1 casein, which is really problematic and inflammatory for most people. So there are A2 cows, like Jersey cows and Guernsey cows, and there are A2 cows, heirloom cows. But, I think what I'm curious about is how this molecule also can be a therapeutic molecule, not just sort of a preventive molecule that deals with some of these basic mechanisms, but how could it affect, your treatment of diabetes or heart disease or fatty liver disease? How does that work?
And that's where it gets to, conveniently, like longevity molecule must have number, what are we on, 4, clinically relevant benefits within months. If a molecule says, hey, we target these mechanisms of longevity, but you're not really going to see anything, but you'll live longer, that doesn't, for Nick and I, that just is not what we were looking for. We're looking for to say, can C15 actually have meaningful benefits, specifically with people with diseases? So again, caveating that as a supplement, supplements aren't intended to treat or prevent or to treat diseases. But we're talking about the studies that have been done to date and what we're seeing. That, we need C15, and putting C15 back into our system and optimizing those levels, we are seeing disease-treating effects. And this is both in people. So let's take, for example, a clinical trial with Dr. Jeff Schwimmer, fatty liver disease, right? So that didn't exist. Non-alcoholic fatty liver disease are now MASLD.
They changed the name because
a rebranding.
you used to only see this fatty liver issues in alcoholics.
That's right.
And now the most prevalent form is those with metabolic dysfunction, meaning diabetes, prediabetes, and they call it metabolic associated fatty liver disease.
I maybe us docs and scientists should be involved in branding a disease name. So
NAFLD as opposed to NAFLD.
so there you go. So I'll call it fatty liver disease, not associated with alcohol. So, that wasn't known until Mayo Clinic published a paper in 1980 for the first 20 cases. And then, so since then, we fast forward to today, the latest paper showed 38% of people globally have fatty liver disease. So this has been a alarming rise in people with fatty liver disease, a percentage of which are progressed to steatohepatitis, inflammation, cirrhosis, becoming one of the leading causes of liver transplants and liver cancer.
I mean, this is important. What you said was really important because, about 1 in 10 or less, the 1 in 9 now keeps getting worse in America have diabetes, type 2 diabetes. But what you're saying is 4 in 10, almost 4 in 10 have fatty liver disease. Even if you don't have diabetes, it still increases your risk of heart attacks, cancer, stroke, rapid aging, and death.
That's right. Now, none of we don't want any of those.
Even if you don't have diabetes.
That's right.
Right.
That's right.
So it's important, and it's often not diagnosed. It's often missed. There are now really great blood tests you can do to find out if you have it, not just your regular liver function test. And we offer these as part of Function Health's testing. So you can go to functionhealth.com/mark and actually get these tests as add-on tests to the basic function panel that look at fibrosis in the liver and are really helpful to kind of pick up people who have this, because you don't want to continue to have this if you have it. I mean, you can diagnose it through an MRI or various kinds of fancy testing, but through a simple blood test, you can also kind of get a pretty good idea. And it's important to understand because this is a silent epidemic that nobody ever heard of, and it doesn't really have a ton of symptoms other than maybe you're overweight and maybe you got a big belly or maybe but it's quite important. And so what you're saying is that C15 has the potential to impact fatty liver disease.
Yeah, exactly. And so when Jeff Schwimmer is a leader in pediatric fatty liver disease, and he opened the first clinic for fatty liver disease for kids. And so Jeff, back in 2012, had published a paper on fatty liver disease in dolphins. And he sent me an email, and he's like, it's probably not what we're seeing in people. Like, it's probably not the same disease, but send me some liver slides that you have, and let me get back to you. So I sent
These were dolphins who died, and then you found it, right?
Exactly. Dolphins who had, exactly. And then afterward we had found.
You're not like sacrificing dolphins to
no,
get the tissue specimens.
Yeah.
It's not like they do mice. Right?
Thank you for that clarification. Yeah, we're actually able to go back and look at pathophysiology reports of dolphins that had passed. So we had this. That was another amazing archive, right, of information. So we were able to send those slides to Jeff, and then a couple weeks later, Mark, I got an email, and the title was "We Are a Go." He's like, "This is the exact same presentation of fatty liver disease that you're seeing in dolphins that I'm seeing in my kids." And he's like, "You're blowing my mind because dolphins don't eat sugar. They're not eating trans fats. It's not ultra processed foods."
That's what I'm wondering.
Right, and it's just like, what? And so that started our 10-year journey in which we have worked together but independently. That Jeff then did a study in which he looked at 237 kids, and he did, at the time, they didn't have your wonderful test, which everybody should get the test that Mark just mentioned to assess your liver, regardless of who you are and your age.
Yeah.
Everybody should get this test. So Jeff did this study, and he looked at these kids, and he showed that the higher their C15 was correlated with lower liver fat. And this was a linear correlation. So the higher the C15, the lower the fat in the liver. So he's like, okay, well, that's interesting. So then that resulted in him doing a randomized placebo-controlled clinical trial with fatty 15, with C15 supplementation among young adults who were graduates who had a history of fatty liver disease.
Wow.
And what he found, there were really key important things that happened that he found. The first is he found that 2 out of 3 of the people in his study had the definition of a C15 deficiency. 2/3. So if you have fatty liver disease, you had an even higher risk of what we were saying the general population has.
1 in 3 to 2 in 3.
Yeah, exactly. And then for the people who took C15 supplementation and got their blood levels above that threshold of deficiency, they had lower liver enzymes, lower ALT, lower AST, and improved red blood cell health within 12 weeks. So now the leading hypothesis and what we have found in the dolphins is that nutritional C15 deficiencies may actually be the cause, or at least one cause, of a substantial phenotype of fatty liver. Because why did it show up? Why did this show up all of a sudden and affect so many? So that is obviously raises
because sugar and
urgency.
starch is a massive part of our diet, and I think it's probably, in my view, a combination of the increase in sugar and starch plus
The
the
C15.
C15 deficiency, right?
Yeah, and for us, we keep going back to the dolphins, and for the we call this the dolphin phenotype of fatty liver disease. The only change they had moved to they were eating a high fat fish called eulicon, which is called a candlefish. It has so much fat in it that you can stick a wick in it. You could dry it, stick a wick in it, and be a candle. Yeah. That fishery died out in the 1990s.
Yeah.
And so that's when they moved to this lower fat capelin. And so at the same time that humans, we were moving away from whole fat dairy and our C15 sources, the dolphins were going on a low C15 diet, and fatty liver disease pops up.
Well, the Native Americans, you might not know this story, but the Native Americans used to trade in these really highly fatty little tiny fish as part of their trade. So if you were a Pacific Northwest Native American, and you would trade with inland tribes and use the fish as your currency. So instead of dollars, you'd give them fish, and they'd give you beads or whatever else they wanted. So that's fascinating, because it was such a valuable commodity back then.
Yeah, and now we understand even more so, how valuable that was. So that kind of, as far as, we also know that C15...
That's a human trial. It seemed to be...
That's right, yeah.
Really
and so
impressive.
That was published last year.
Directionally showed what's possible. Like, it didn't cure their fatty liver disease, but it seemed to sort of create a downward trend in the effects, and you still have to cut out the sugar and starch.
Yeah, we need to look at the whole picture of lifestyles and how we're changing things. What's interesting is it really goes against the whole idea of all saturated fats are bad, and that we have one that's essential. So it's how do we get it back into our diet?
Yeah.
So there's a lot of you could feel the urgency around this movement. The reason for the book is really to help increase education, and let's have the conversations around. See, we can't explain it away anymore. So
And what kind of studies have there been in humans around diabetes, type 2 diabetes, and heart disease? Is anything?
So with regard to there was a second study in Singapore, and that's one I had mentioned. That was also fatty liver disease, women with fatty liver disease, and it showed that it lowered LDL cholesterol and then improved the gut microbiome. That was an interesting study, because what they did for this clinical trial, and this was also a controlled clinical trial, that they had, the control group was one that went on a hypocaloric diet. So they had they had an average
low-calorie diet.
Yeah, exactly, 1,000 calories per day. That'd be tough to sustain. That was the first group. The second group was a low-calorie plus Mediterranean guidelines, which both of those have been shown to help with fatty liver disease metabolism and various components.
Ketogenic diet works best.
Even better. You're spot on. And then the third was low-calorie Mediterranean plus C15 supplementation. So it was a big lift to ask of C15. In those groups, not only did the third group, the C15 supplementation, result in lower LDL cholesterol and improved gut microbiome, but it also had the greatest loss of liver fat, the greatest loss of body fat, the greatest glucose improvements, but it was trending. It was not statistically significant. You just kind of saw the step. But again, it was 12 weeks.
Yeah.
And so the question is dosing, timing, things like that. In numerous studies of these meta-analyses, right? Studies of studies that prospectively follow thousands of people over decades, numerous studies have consistently shown people with higher C15, just like we saw in the dolphins, lower risk of developing type 2 diabetes, of heart disease, specifically coronary heart disease, of developing fatty liver disease and certain types of cancers, specifically a lot of work on colorectal cancer. This is why, with all these different aspects of the data, from epidemiological data, clinical trials, mechanisms of action, in vivo efficacy studies, this is why Dr. Nick Shork, he was at ARDD, which is one of the world's leading anti-aging therapeutics meetings. He was in Copenhagen last year, and he presented C15. He said, listen, I've seen every longevity molecule under the sun, and I've not seen a molecule that has more supportive data of being a longevity enhancing molecule than C15.
But most people have never heard of it and don't know about it.
Right. And it's like, what? So then, until now.
Yeah.
Right.
That's why you wrote the book and why we're having this podcast, so people can understand this sort of emerging science around this, which is kind of cool because it's not very often you come up with a new discovery like this. And it's pretty cool. There's a few questions I have around the foods to help people understand what foods they should be eating. We kind of touched on a little bit. But what are the foods that are highest in C15?
So probably not the groups that you're most excited about. Dairy fat, by far is our primary source.
But depending on
C15.
what the cows are eating.
Depending upon what the cows are eating.
Or what the sheep or goat are eating.
Exactly. Right. And so C15, for a long time has actually been used as a biomarker of how much dairy fat people ate. They didn't know that it had any meaning. So it was used as a reliable marker of how much. So that's how much, dairy fat, and again, dependent upon what that animal was eating, really drives our C15 levels. It's a big reason why we, the Navy funded, again, our development of the C15 supplement, because it's a pure free fatty acid supplement that's bioavailable. Just as importantly, it's vegan, and it is not having to compete with all of these pro-inflammatory fatty acids.
So with the good comes a lot of the bad in dairy, and that's what you want to avoid. Yeah,
that's right. Yeah. Otherwise, we
well,
would
it's
have
interesting.
just...
Some of the studies, looking at, and these were epidemiological studies, we're looking at, people who eat more dairy seem to have less diabetes, right? So that's interesting. Is it the dairy fat? Is it something else? Is it the saturated fats that protect them? I don't know, but it's just sort of makes me wonder.
Yeah, it's it's the dairy studies are super messy, and so there are absolutely studies showing this benefit. There was a recent study that looked at this to say, hey, why do some studies show that people who eat more dairy have a lower risk of a given disease, and other dairy studies don't show it? And so what they were able to narrow down to, and they concluded, was that C15, higher levels of C15 were one of the main predictors of having a benefit. Higher levels of C18 was a predictor of having it being harmful. So again, it's not...
And that's another fatty acid that's saturated in dairy fat.
That's right. Yeah. So it's, and that's not going to be the simplistic answer.
Yeah.
But I think it's, the more we can understand how to maximize C15, and maybe having a ratio, like we have omega-6 to omega-3 ratios, maybe it's an even chain saturated fats, which are these pro-inflammatory fats, to C15.
Yeah, I mean, that's the thing people don't understand. People say saturated fat's bad, and saturated fat's good. I mean, there is no such thing as saturated fat. There's saturated fats.
Yes.
And each one has different properties and different benefits and different risks, and so uniformly they're not the same.
Spot on.
And they don't affect your lipids the same way, your health the same way. I wrote a lot about this in my book, Eat Fat, Get Thin, because people were super confused about it. I think that just to kind of sort of sum up what I'm hearing is that this is like a newly discovered molecule that is an essential nutrient that 1 in 3 of us are missing, that has profound effects on many of the longevity pathways that have to do with aging, mitochondrial health, blood sugar health, microbiome health, affect your liver health, cholesterol. I mean, it's almost too good to be true, right?
Yeah, we hear that. And and I think we get down to it's essential.
Yeah.
It's just one of those rare molecules where we need it.
And what's beautiful about these molecules is they're not needed in huge amounts, right? So when you think about a vitamin like vitamin C and scurvy, it only takes like 60 milligrams of vitamin C to cure scurvy, which is a deadly disease if you don't have enough vitamin C. And by the way, 10% of Americans don't have enough vitamin C to prevent scurvy.
Which is mind-blowing, right?
Which is because they're eating ultra-processed food, and they don't get any green vegetables, and they don't get any fruit. And so, yeah, it's a big problem. But what I find interesting about vitamins is that they have very, very powerful effects, or essential nutrients, at very low levels. And without them, our whole metabolic and biochemical machinery doesn't work the way it was designed to work. And so things go wrong. And the things that go wrong are the things that we don't want to go wrong, like, damaging our ability to keep healthy cells, right? The cell fragility syndrome, where your cells don't function properly and the membranes aren't right. And fats make up your cell membrane, so they have to be healthy, and this is a key component of that. We have to regulate our mitochondria properly, our immune system properly, free radicals and oxidative stress properly, our microbiome. So it's interesting that it sort of seems to work in so many different ways. And I think, there's a word that probably people have heard me talk about that is pleiotropic, meaning it has many different effects. So drugs usually have a single effect. They might have a few other side effects, but they're designed to be a single drug for a single biochemical target with a single receptor, with a single outcome, working on a single pathway. And what nutrients do, like, for example, magnesium activates over 300 different enzymes in the body. So it's so does zinc, or maybe 200 different enzymes. So these are highly, I think vitamin D controls, hundreds and hundreds of gene expressions throughout your genome. And these are multifunctional molecules that go beyond what we would normally think of as a pharmaceutical intervention. So these are the things that create health as opposed to simply treat disease. And I always say, when you create health, disease goes away as a side effect.
I love it.
And that's kind of what you're talking about here. This is a component of our biology that we've neglected, that we haven't known about, that has been recently discovered thanks to the dolphins and you.
We'll thank the dolphins. This was truly gift.
And just, having an observation that, wow, geez, these dolphins aren't living very long. These are living longer. Like, what's up with that? And just asking the right questions, you were able to come up with this discovery. And I think it's really groundbreaking. I think people need to eat fatty fish. I think small fatty fish is key. If you're not going to eat dairy, like herring, mackerel, sardines, anchovies, all the stuff that people don't like.
Right. You got to get it, let the head and skins.
I'm Jewish, so I like all those things. We grew up on those things that I didn't know at the time.
Yeah. You're already like dosing yourself with C15.
Yeah, tons of cans of mackerel in my cupboard and cans of sardines. And in terms of the dosing, like, what kind of doses do people need of this?
To your point, and that was a remarkable summary, we need about 100 to 200 milligrams per day. So if you compare that to like omega-3s, right, then you're talking more about grams.
1,000 or 2,000 milligrams, yeah.
That's right. So this is, to your point, it's a very low dose of C15. It's 100% bioavailable in the free fatty acid form. So we only need a small amount. And again, in order to help fortify our cell membranes and keep them strong, we need greater than 0.2% of that cell membrane needs to be C15. So we don't need a lot.
Basically a fifth of a percent.
Yeah.
Of the fats in your cells have to be this fat in order for it not to become fragile and break down.
We only need these low amounts to achieve these levels in our cell membranes. We also know what's been remarkable is that all these studies about all these different mechanisms, like activating AMPK, inhibiting mTOR, they're all showing the same concentrations. It's all the same amount that we need in our blood to have all of these many pleiotropic benefits. So it's very consistent. The story just is so consistent on what we're intended to have to stay healthy. Now what we're saying is, hey, can we increase it and push it further? So it's like 0.4 to 0.6%. Can that help us be even healthier and live longer? And there's a big study that was done by a group at Harvard and a bunch of other teams, and they did a large study, and they showed that people who had these higher levels of, instead of 0.2%, 0.4 to 0.55%, that they were less likely to develop heart disease over time. And then, the longevity zones are going through, an evolution, but in Sardinia, the people there they live longer in part because they have a lower risk of developing heart disease, and specifically men live longest in Sardinia than anywhere else in the world.
Yeah, I've been there.
Right?
Oh,
I'm jealous. Okay, so they have a mean C15 level of 0.6. and they have and they've replaced their
That's fascinating,
right, and they've replaced their meat for the most part with cheese.
Yeah.
They're using local cheese
Yeah.
from local goats and sheep.
No,
eating
this
grass,
all makes sense.
high altitude.
What was really
right?
fascinating was when I spent quite a bit of time in Sardinia. I got to meet with a lot of these very old men and old women, and I mean, one couple I think was 210 years old together.
Oh my goodness!
and they were fit and they were vibrant. This guy Pietro was like 95. Was just kind of retired from herding his sheep 5 miles a day up the rocky terrain. And what was really fascinating was they understood that one of these guys, Olinto, said, we flavor our meat before we kill the animal. And I'm like, what do you mean? He says, well, whatever you feed it determines the quality of the meat and the taste. So whether they feel like carob or acorns or whatever, like the black-footed pigs in Spain for the Iberican ham, very different fatty acid profile because all they do is live in oak forests and eat acorns. And in Sardinia, they know that if they take the sheep or the goat and they kind of graze them on different plants at different times of the year, it'll taste better. They're not doing it because it has high C15 levels or they're like looking for better phytochemicals or whatever. They just want it to taste better. The reason it tastes better is that phytochemicals create the taste in food. So flavor always follows the phytochemical richness or density of the food. And they just kind of knew this intuitively by how they raise these animals. And so these animals were eating all these wild plants all the time. That's what they fed them. And so that makes a lot of sense.
Right?
That makes a lot of sense to me, just given sort of being there and seeing what they were eating and what they were eating and ate and what the cheese was made from. And it was really fascinating. Yeah.
That is really cool. Yeah, they're one of their cheeses, right, which you might have seen there was Pecorino, and Pecorino has higher C15 than most other cheeses. So yeah, it kind of feeds into this all kind of neat how that all comes together.
It's really fascinating. I mean, I think what I would love to sort of know from you is where's all this going? Like, what's next? And what are we going to see next in terms of the research that's underway, the things that are promising?
Yeah, well, this is the next step. So we spent 10 years on credibility. That was really important before we even thought of bringing a supplement. And all the research right out is really building the credibility. You could imagine a dolphin veterinarian saying you need to take a saturated fat. You better be able to back that up with really good data. So we went above and beyond with regard to the science. And then now the world has picked it up. So again, you can go to discoverc15.com, and that's where all the peer-reviewed papers, again, over 100 from people throughout the world. So that's a fun place to go.
And it's the letter C and the number 15.
Thank you.
So discoverc15.com. We'll put it in the show notes. But it's a treasure trove of the current and ongoing kind of research.
Yeah, and now probably once every 2 weeks, there's a new paper coming out. So it's really exciting.
So it's not just you anymore. There's people all around the world who've taken up the research around this.
That is right. That is right. Which is really exciting. Now the movement, right?
Well, I mean, that's how science works, right? Somebody discovers something and then other scientists try to validate it or discredit it.
That's right. Yep, that's right. So that's been great to see. So then now we're moving toward exciting new avenues, obviously getting the conversations going. How can we change nutritional guidelines? How can we get C15 for our kids, into infants with all the new studies that are coming out around the importance to infant health, as well as supporting our aging as we get older. And then we have some exciting new research coming out around brain health. So stay tuned for that.
Cognitive development.
Development.
From both spectrums, right? From young cognitive development and also brain aging and
That's
Alzheimer's.
right. Yeah, so a lot of exciting work coming out around that. And then, for us, it's like we have really taken a step back and said, why? Obviously, there's urgency to fix, global crisis that's happening. And if there is a chance that restoring C15 can help with that.
The global crisis of what?
Of just metabolic diseases. The increase. We're
brain
seeing,
diseases
the kids that were born into basically this height of the C15 deficiency world, which is the 1990s, they're now in their 30s. And so is this why people in their 30s are developing certain types of cancers, or the rise in a coronary heart disease, the rise in type 2 diabetes, it's fatty liver disease showing up. And how much is the C15 deficiency part of that? So let's stop accelerated aging. There are kids that are developing diseases of their grandparents before their parents.
Yeah.
So we
Yeah.
got to fix that. And then how to then, again, leaning in, how do we optimize C15 through supplementation, through various practices to be able to extend our longevity. So that's exciting. And then what is it all for? I mean, longevity so we can live healthy for as long as possible and enjoy life. And
Yeah.
I have a question for you,
Yeah.
which is, it's to give us more time.
Yeah.
And so if you were given 2 extra hours of every day, and those 2 extra hours, whatever you did was guilt-free. You didn't feel guilty about it because you weren't working on something else because you're so busy. What would you do with those 2 hours?
2 hours a day? That's a great question. I probably would exercise more.
That's great. It's more time to be able to do things because
Yeah.
makes you feel good,
Yeah.
right? And then it makes you healthier and it feeds all those things. And so for us, it's the ability to say everybody has the right to longevity, to live a long life, to have a meaningful life. The book is about the purpose that fell in my lap through the Dolphins, and let's give us all more time to
Yeah.
be able to fulfill our purpose.
I'm excited to see what's next. This is very exciting. You can read about this in great detail in Stephanie's new book, The Longevity Nutrient, The Unexpected Fat That Holds the Key to Healthy Aging. It's out now, so you definitely should check it out. Also, if you're interested to learn more, go to discoverc15.com, and you can actually buy C15 as a supplement, and it's called Fatty 15, which I love and I take. I just take 2 capsules a day, and that's it. And it's pretty straightforward. It's a low friction way to get it. If you don't like sardines and herring and mackerel, hopefully I'm not overdosing because I do eat those. But
No overdosing.
I think we're kind of in this moment where we are discovering a lot about aging and longevity, but we can't miss the forest for the trees, which is the fact that we're eating a diet that's killing us, and the amount of sugar and starch is driving our metabolic crisis, is causing a lot of the things that are going on. I think C15 can be helpful in mitigating that, but without actually also changing your diet, exercising, getting enough sleep, managing stress, having connections and relationships, it's not enough, right? So
that's right. It's part
of the
of
overall
the
package,
solution.
right?
But boy, all those things are so important.
Yeah, exactly. So you don't want to eat your C15 supplement and
Not
just
exercise and
have
socialize.
3 cans of soda a day. So
That's right. Please don't do that.
So thanks for coming on the podcast again. This is really great. Everybody can find out more, and we'll put it on the show notes for the links that we talked about. And keep up the good work, and we'll stay tuned for what's next on the horizon.
Great. It was great to be here, Dr. Hyman. Thank you.
If you love that last video, you're going to love the next one. Check it out here.